Chilling with Miss Miller, where our motto is filling Algebra 2 problems in a bird-chilling way. With our cool co-host, Crystal. Welcome and enjoy the show. Okay, let's turn that off. All right, you guys, so here we are. So far we have simplified rational expressions, we've multiplied, we've divided, now we are adding and subtracting. So remember that rational expressions are fancy fractions. So let's really quickly review how to add and subtract regular fractions that just have numbers in them. So, anybody remember the rule? There's a rule that we have to follow when we are adding or subtracting fractions. Thane. Common denominator. Everybody give it up for Thane. Yay. So, common denominator. And if they already have a common denominator, like this first one, 1/20th plus 9/20ths, what's that? Aiden? It would be 10/20ths. Everybody give it up for Aiden. All right. So you actually do whatever is being said to do, like add here. Add those together on the top, and then the bottom stays the same. Now, we always go back and see if we can simplify. 10/20. What? No, announcements for leading edge. All right, Zach. 1/2. Everybody give it up for Zach. All right, so we divide out anything that they have in common and reduce. All right, now, in the case of the next problem, 1/4 plus 3/5. Now what do we do? Sloan. Good, get a common denominator. Everybody give it up for Sloan. Clap if this is a review. Clap if this is a review that you are all enjoying thoroughly. Oh, all right. Clap if this is a review that you are not really enjoying that much. At least we have honest students. That's good. Okay. It is necessary, though, so you all can see where we're going. All right. Common denominator of 4 and 5. 20. Excellent. So, the question is, what do we have to multiply 4 by to get 20? Alan. 5. Everybody give it up for Alan. Okay. What do we have to multiply 5 by to get 4? Alan, go ahead again. 4. 4. Okay, everybody give it up for Alan again. Alan again. Okay. All right. So when we multiply this first one, 1/4 times 5/5, what do we get? Aiden.
You would get 5/20.
Good. 5/20. Give it up for Aiden. Okay, the next one, 3/5 times 4/4. Aiden again.
You would get 12/20.
Cool. Give it up for Aiden again. All right. 5/20ths. Now we have the same denominator. 5/20ths plus 12/20ths, like we did in the last problem. Somebody other than Aiden and Alan and Thane. Tyler. 17/20ths. Everybody give it up for Tyler. Okay. So here is the beautiful thing about today. We are only focusing on like denominators. Yay. In a homework, we're only focusing on like denominators. We get to do the unlike ones on Thursday. Okay, so here we go. We want to do our little test. 5 plus y over y, that's a plus 7 over y. Zach.
12 plus y over y.
Good. How'd you get that?
I just added the 7 and 5 and left the y alone.
Good. So why were you able to add the 5 and 7 together to get 12?
They're like each other.
They're like each other. Excellent. Everybody give Zach a round of applause. Or an A. A. My daughter does that. I just realized that. Okay. Now, correct me if I'm wrong. You know what would be really cool is if we could get to a point where everybody just immediately can respond to this without me having to ask it. Anybody know what I'm going to ask before I actually ask you something about this 12 plus y over y? Yes, you know what I'm going to ask, or no? The answer to the question is no. Okay, so what's somebody tell me the question that I'm going to ask. Thane?
Can we reduce this?
Good. Can we reduce this? Answer?
No.
Yes.
Wait a minute.
Yes.
Can't I cancel out the y's? Haven't we been canceling out stuff that matches? That's the question I'm going to keep asking. Why can I not cancel out the y's? What? Sloan?
Oh. Because they're two separate terms and they have their own parentheses.
Good. Okay, so everybody give it up for Sloan. Think of them as both having their own sets of parentheses around the entire thing. 12 plus y is a different thing than y. Okay, so if it helps you to put the parentheses around it, put the parentheses around. Questions? Okay, let's move on. Next, a over b plus 2 minus b over b plus 2. Anybody feel like coming up to do this one so we can play our music again? I'm missing the music in this class. Okay, let's see. Shuggy? It's a minus. Okay, so is that a no, you do not want to come up to do this? No? Somebody else want to come up and do it? Let's see. Let's have, trying to think who has less extra credit between all of you. Zach, I think you might have less. Come on up. Everybody give it up for Zach! Yeah. Let's get our second song on. Our backdrop is coming on. That's nice. Nice touch.
Yeah. Here we go. Yeah. Here we go.
Everybody give it up for Zach! Hey, nicely done. Nicely done. Okay, you know what question I'm about to ask, right?
Yeah.
I see some things that look like they should be able to be canceled here. He ended up getting a minus b over b plus 2, but, again, shouldn't that be reduced? No, it shouldn't be reduced. Liz? Yes. Good. Everybody give it up for Liz. Nicely done. Okay, questions? All right. Next. X squared minus 19x plus 4 over x minus 5 plus 2x squared plus 5x minus 9 over x plus 5. All right. Same denominator?
Yep.
Yes. So, can somebody tell me what I do now that I have the same denominator? Well, I already have the same denominator. Aiden? You add the tops together. Everybody get up for Aiden. Okay, so if we go through, let's combine the like terms all in one step. So we have 1x squared. Everybody shout it out. Ready? Ready to shout?
No.
Ready to shout?
Yeah.
Ready to shout.
Yes.
1x squared plus 2x squared.
3x.
Okay. Negative 19x plus 5x.
14x.
Good. 4 minus 9.
-5.
Negative 5. Cool. Everybody give it up for yourselves. That was weak, though, I will say. Okay. Now, 3x squared minus 14x minus 5. Are we done?
Yeah.
I see
Yes.
2x minus 5s up here. I can cancel them out, right?
No.
No.
All right, Zach, what's up?
Oh, I was going to answer.
Go ahead.
Because you have to imagine that there are two parentheses around them, which hence make them into one unit.
Perfect. Perfect. So he's answering why I can't cancel out these x minus 5s. And he said, imagine that there are parentheses around them. Two totally different things. Give it up for Zach. All right. Am I done? What do I do next? Diamond. All right. Nicely done. What goes in the top of the diamond? Aiden?
Quiet.
Okay, everybody pay attention. Top is negative 15, bottom is negative 14. Something that came up last period is they thought that the top was negative 5. Where are they getting that -5, and why is that inaccurate? Go ahead.
Well, they would get the -5 if there was no 3 in front of the x. But
Right.
because there's a number, you multiply the 3 by the -5, which is c.
Excellent. You always have to multiply a times c. 3 times -5, -15. Give it up for Aiden again. All right, what goes in the sides? Two numbers. Everybody think about two numbers that multiply to -15 that also add up to -14. Two numbers that multiply to -15 and also add up to -14. Lorenzo?
-15 and 1.
Good. -15 and 1. Give it up for Aiden. Or Lorenzo. Lorenzo. Give it up for Lorenzo. Sorry. Aiden has been having his hand up over and over again, so it was out. Everybody, okay, now we have to make this right. Everybody give it up for Lorenzo. There we go. Okay, sorry. Okay, what goes on top of the fractions? Sloan?
Oh,
3x, cool. Everybody give it up for Sloan.
I thought I was answering the last one.
Okay, so we have 3x. Anything that can be reduced in those fractions? Somebody other than you guys. You guys are always... Yeah, you guys are on fire. Let's let other people have a chance. So, Deanna. Cool. What does that reduce to? 1 and -5. Everybody give it up for Deanna. All right, and we have this x minus 5 on the bottom. So this comes out to, let's move this up so you all can see, x minus 5 times 3x plus 1 over x minus 5. Okay, anybody see anything that we can get rid of? Somebody other than Aiden. Liz. Good. Everybody give it up for Liz. The x minus 5s go away. Everybody give it up for Liz.
Hey.
What's my final answer? Somebody other than you guys. Lorenzo, you haven't volunteered as much. Go ahead.
3x plus 1.
Cool. Everybody give it up for Lorenzo. All right. How are we doing on questions, you guys? No questions? Whoops. Last problem. Everybody have this? Can I change it?
Yes.
All right. Last one. I put this up here for a very specific reason. So this problem, you guys tell me, x minus 5 and 5 minus x, those are our denominators. Are those the same? No. They both have, but they both have an x, they both have a 5, and they both have a minus. So are you're telling me that's not the same thing? Desi? Good. Negative x, this one would be negative x plus 5. Exactly. Everybody give it up for Desi. Okay, so the question is there a way to get them to be the same? If you guys notice, the only difference is the signs are different, right? So there's something that we can do to one or both of these so that the signs become the same. Rebecca? Say it louder, I can't hear you. Good. What? Good. So she said multiply by something to get it to be positive. Any ideas? Oh, Thane could not contain himself. Everybody give it up for Rebecca and Thane. So Rebecca was right, and then Thane said -1. Excellent. So we have to multiply both the top and the bottom by -1. Just like we did in our regular fraction in the very beginning, if we multiply by something over something else, we're changing the fraction. We don't want to do that. Okay, so let's distribute the -1 everywhere here. So we get 3x squared plus 4 over x minus 5. This minus in between, that doesn't change. That comes straight down. Now, can somebody tell me when I multiply the -1 through what I get? Sloan?
Negative x squared plus 7 over x minus 5.
Okay, I'm going to write it this way. Everybody give it up for Sloan. Bear with me. I'm writing it this way for a reason. 5 times -1 is -5. Negative x times -1 is positive x. And I'm going to just play devil's advocate here. This and that, to me, do not look the same. But they are. Why? Okay, I heard Sloan say if you switch them, what do you mean switch them? You're right.
Like place the x in front of the 5, it would just be the same.
Good. Place the x in front of the 5 and then the 5 in the back. Everybody give it up for Sloan again. Okay. Now what do we do? Now we have the same denominators, so what do we do? Aiden?
We would subtract the top.
Good. Now, you have to make sure that this negative sign gets distributed to both of these terms because you are subtracting both of those terms from the previous two terms, okay? So, Aiden, you tell me, when I distribute that negative sign, what do I get?
You would get positive x squared minus x.
All right, everybody give it up for Aiden. Okay, then, what next? Somebody who has not volunteered yet today. Don't all jump at once. It's cool, I'll stand up here for a while. Somebody who has not yet volunteered today. We have this in our problem. Nicole. Michelle, I'm sorry. Michelle. Excellent. Combine the like terms. So 3x squared plus 1x squared is how many, Michelle? Good. And then 4 minus 7 is? Negative 3. Everybody give it up for Michelle. Okay. Nicely done. All right. Questions? Okay. You guys have a homework assignment up here that is due at the end of the period. It is 7 problems, and a lot of people finish in about 10 minutes. Oh, that Shuggy is telling us that she is done. Okay, everybody send us off that we are done with our lesson. Yay!